Welcome back, students. In this video, we're going to cover Lesson 4-2, Translations. The standard for this video is under the title. Go ahead and jump in. This should be a quick video. So, key topic here, or key concept, excuse me, a translation is a transformation in which all the points of a figure move the same distance in the same direction as described by a translation vector. All right, so a vector, they're going to give us, with the little pointed parentheses, A comma B. The A is your horizontal, or your X, and B is your vertical, or your Y. So the numbers go in here, and they'll be associated like this. Your X comma Y becomes X plus A, so we're adding whatever A is to X, and then Y plus B. So we're going to add the B to the Y coordinate. And it says plus. Of course, if these numbers are negative, you're going to subtract it, but we have to say plus because these are just, they're positive until stated otherwise. So, back over here. So, when a translation has been applied, the distance between each pair of corresponding vertices is the same, and the segments that connect each pair of corresponding vertices has the same slope and are parallel. So, it's just basically saying, if we're going from ABC to JKL over here, the distance from B to K, the distance from A to J, and the distance from C to L, they're all going to be, they're going to all correspond. They're also going to have the same slope, and they're all going to be parallel because these 3 points don't touch. Those 3 lines that connect the 3 would not touch. The magnitude of a vector is its length from initial point to the terminal point. So this guy moved that far. It's represented in this little arrow here. So let's take a look. Example 1, and I may post some shorts, pull some random questions from the practice from each of the 4 sections in chapter or module 4. Once we get through the guided notes videos, so we'll see. All right, so example 1: determine whether a translation maps DEF onto LMN, and if so, describe the translation using words and coordinates, and if not, explain why. Okay, so we're going DEF to LMN. So we're going from here to here. Let's see. Now, keep in mind, so these letters correspond. D and L are your first letters; those correspond. So D and L. E and M, and F and N. So if you're going to check this, you have 2 different methods. I'm going to show you both. First, we can check our corresponding vertices and see how far we move left to right and how far we move up and down. So let's just start with E. We're going to count from E to M. So we're going, first we do left to right, then we go up and down. That's how our X comma Y is written. So 1, 2, 3, 4. You get to where you're lining up here. So we went 4 to the left, and so left and down are both negative, and up and right are both positive. So we went left. You may want to get in the habit of counting. If you're counting left or down, just say negative. So -1, -2, -3, -4. So we went left 4, or -4, comma, and then we're going down 1, -2. Remember, down is negative also. So down 2, or -2. This was from E to M. We're going to do F and N and E and M by sight, and then I'll show you the math part from D to L. So from F, again, so left is -1, -2, -3, -4 to line up here. And then I go down, or -1, -2. So from Fn, we went -4 or left 4, -2. So it's also same vector. All three of these should be the same. If not, it doesn't map onto itself, meaning this is not the same shape. All three of your points should correspond the same way. All right, so let's look at the last one. So D and L. So we're going to write these over here. Point D, so we're going to start at the origin. D is 1, 2, 3. And then my Y is 1, 2. So D is at 3, 2. And then L, so from the origin, L is just left 1 or -1. We didn't go up or down, so it's just -1, 0. So we can take these 2 points and kind of figure. So on a number line, so I'll draw you a little number line over here. So here's 0, 1, 2, 3. And we got to go -1. So from 3 to -1, we would count backwards, or left or negative. 1, 2, 3, 4. So that was over 4. Over 4. And then from 2 to 0, 1, 2. Left or -2. So check, check, check. So this is translated along vector -4, -2. So then they said, describe the translation. So using words and coordinates. So that's what we gave them. If not, explain why. So if all three had not lined up, then we would say that it didn't map onto itself, or it's not a translation. But we were able to here. All right, so going down to the page here. Example 1 check. So you guys are going to work this. So they want you to determine if QRS maps onto UVW. So this guy to this guy. If so, describe the translation. So you're going to count, and see if they all match up. And if not, then you'll explain that they don't map, or it's not a translation. And if they do, you're going to say, yeah, it was left whatever, right or down whatever. So map this guy out. We're going to flip to the other page. All right, apply example 2. Travis is on a scavenger hunt at the lake. He needs to swim to the nearest buoy, pick up a card, and then he's going to swim until he reaches a fisherman, who will give him the next clue in exchange for his card. Describe the translation from the buoy to the fisherman's boat using coordinates. So we're going to fill in the blanks here. Now, this is our origin. So this is 0, 0. So to count the buoy, and it's really hard to see the lines, but there is a line here and there is a line here. So the buoy, and there's a line here, here, here. The buoy is 1, 2, 3 over. So +3, and then it goes up 1, 2. So the buoy is at 3, 2. And then if we count over here, 1, 2, 3, 4, 5, 6, 7, 8. 8 over and 1 up for the fisherman's boat. So 8 over and 1 up, or +8, +1. They want us to describe the route. Well, from the buoy to the boat. From the window to the wall. Aha. From the buoy to the boat. The 1 or 2 of you guys that caught that during class the other day laughed. The rest of you either didn't hear, or that music's too old for you. All right, so now, what coordinate rule can be used to describe Travis's route? So let's see, how did we do it? Flip over my page here. All right, so we look at our x's. So we went from 3 to 5. So from 3 to 5 would be, from 3 to 8 is 5. So we went +5, because this is all going to be, well, this is positive. Remember, up right is positive, Left is negative, up is positive, down is negative. So we went 5 to the right, or 5 positive. And then from 2 to 1, we went down, or negative 1. And then let's see, a coordinate rule. So that's your vector. But your coordinate rule, remember, it's x plus a, because in the vector, a is the left, b is the right, a is the x, b is the y. So it's x plus 5, y negative 1, y minus 1. So there's your coordinate rule. All right, apply example 2. You guys are going to handle this one. Notice, so this is positive, this is positive. You're going to take the coordinates for this trail, and you're going to get the coordinates for the lodge. And I'm going to highlight this because it's really tough to see this. So the lodge, see, it's after 10, and this one is between 4 and 6. I'm doing this because in class we got a little confused with being able to read it. So maybe that'll help you a little bit. Actually, we'll just tell you. So this is 5, this is 6, and then over here 11. So you should have all the numbers you need for your coordinates and to be able to describe that guy. Practice, we did 1 through 12. The summary is talking about this picture over here. It's asking if this is mapped to that. And, so this is a little bonus for you guys that are paying attention, because I'm not going to write it down. But if you need me to tell you that those two shapes, like over here, if you need me to tell you that those two shapes are not the same size, then we need to go to the eye doctor, children. So again, if you're listening and not just taking notes, you'll understand that that's not a translation, because those are not the same figure. Okay, any questions, let me know in the comments in class. Please subscribe if you hear this, especially my students. You get extra credit. Just make sure you show me, because I don't see who the subscribers are. So bonus points if you subscribe and let me know next week in class, or whenever you hear this. I'm just happen to be videoing on a Friday night. So until next time, have a good night.